Revise with me video on probability tree diagrams. So the thing to remember with probability trees is that all probability adds up to 1. So all probability adds up to 1. And when they say and, that means times. And when they say or, that means add. So when you go across a tree diagram as well, that's times in, and when you go down, up or down a tree diagram, that's the same as or, so that means add. So those are 3 things you basically need to remember. So question 1. A bag contains 7 blue balls, 5 green balls, and another bag, 4 blue balls, 6 red balls. So we've got a tree diagram drawn. First bit is we got to complete it. So using the first rule, all probabilities have to add up to 1. If this one here is 7 out of 12, so if you've got 7 out of 12 for the blue balls, that means we've got 5 out of 12 to choose green. Now, in your question, in the second bag, it said it contained 4 blue balls and 6 red balls. So for blue is 4, 6 add 4 is 10, so it's 4 out of 10, and red is 6 out of 10. Now, bags are completely different, so just because you choose 1 out of one bag doesn't mean you're going to choose a different one out of a different bag. So these probabilities stay exactly the same. They are independent of one another. Right, that's 2 marks for just completing that tree diagram. Okay, so second bit. So complete the probability that both balls are blue. So this means you want a blue and a blue. That means you need to times. So when we go across, we want a blue and a blue. So we need to do 7 out of 12 times 4 out of 10. When we are times in fractions, we can just times the top. So 4 times our 7, which is 28, and 12 times the 10, which is 120. Right, calculate the probability that at least one ball is blue. So this means that if we want a blue and then a blue, or a blue then a red, or a green then a blue. So that's all 3 there, so we can do all 3 and then we can add them all up. There is another way to do this one, I'll tell you at the end. So we can do blue, so 7 out of 12, and a blue, because we want at least 1. That could mean 2. So we just done that one, which was 28 out of 120. Then we've got blue and red, so we've got 7 out of 12 times the 6 out of 10, so 7 6s, 42, out of the 12 over 10, which is 120. Then we can go green, 5 12ths, times our 4 tenths. So 5 times 4, 20, out of 120. So what we need to do now is we need to add up all of these fractions. So don't forget, you don't add the bottom when you're adding. So we need to do 28. So we need to do 28, add our 42, add our 20, gives us 90 out of the 120. And we could simplify that, but it doesn't ask us to, so why bother? Right, next one. So we've got a fair dice and a bias dice. So we should know the probability of rolling a 4 on a fair dice. So how many 4s are on a dice? 1. How many sides on a dice? 6. So if the probability of rolling a 4 is 1 out of 6, probability of not rolling a 4, well, that's 5 out of 6. Because don't forget, they've got to add up to 1. Right, the bias dice, we've got 1/3 is a chance of rolling a 4. So not rolling a 4 gives us 2 out of the 3. So don't forget they've got to add up to 1. So because the bottom number is 3, they've got to add up to 3. And bias dice stays the same, even if you roll a 4 or not a 4 on the fair dice, so that stays as 1/3, and that stays as 2/3. Okay, we filled in our tree diagram, so our 2 marks. Now we've got to calculate the probability that both dice show 4. So that means I want a 4 and a 4. Don't forget, and means times, so I've got to do 1/6 times 1/3. 1 times 1 is 1. 6 threes are 18, so it's 1/18. Right, next one. Calculate the probability that exactly one dice shows 4. So I only want one showing 4. So I want a 4 and then not a 4. And I want not a 4, then a 4. So I only want 2 options. So I want those 2 and then I want to add them. So I want a 4, 1/6, and not a 4, so 2/3. So 1 times 2 is 2. 6 threes are 18. Then I want a 5/6, not a 4, and a 1/3, which is 5/18. We now need to add these up. So don't forget, when we're adding fractions, we don't add the bottom, so it's just 2. Add our 5, which is 7/18. Right, each lunchtime, Paul either eats a packed lunch or he eats a sandwich brought in the snack bar. Probability that he eats a packed lunch is 3/5. Whatever he eats for lunch, the probability that he buys a mug of tea is 3/10. So it doesn't matter what he eats for lunch, the mug of tea stays as 3/10. So we know these are independent. So if the packed lunch is 3/5, we know that he buys a sandwich is going to be 2/5, because they've got to add up to 1. After his lunch, so after his lunch drink, he has a tea, is 3/10, so not tea is going to be 7/10. So 3 and 7 make 10, so that's how they add up to 1. So tea stays the same because it's independent, and 7/10 stays the same because it's independent. We've got our 2 marks for filling in our tree diagram. This is the trickier bit now. So we've got calculate the probability that Paul eats a packed lunch and he buys a mug of tea. So we want packed lunch and tea. So we want 3/5 and 3/10. So 3/5 times 3/10. So we got 3 3s are 9 and 5 10s are 50. That's it for that one. Next one, 2 bags contain some coloured balls which are identical except for their colour. One ball is taken at random from each bag and their colours noted. The probability of the selected ball from the first bag being red is 1/4. So this bag here, 1/4. Probability of the selected ball from the second bag not being red is 2/3. Okay, so we got to fill in the rest of our tree diagram. So we've got 2 separate bags. So if the first one is 1/4 for choosing red, we know not red is 3/4. On the second bag, if we know not red is 2/3, we know red is 1/3. And that is going to stay the same no matter what you choose in the first bag. Doesn't matter what you choose in the second bag. So they're independent again. So we've got 2 separate bags. Might be a little bit different if they're the same bag. Right, first one. We've got to calculate probability that both balls are red. So we want red and red. So we're going to do 1/4 times 1/3. 1 times 1, 1. 4 times 3 is 12. So it's 1/12. So next one, we've got to calculate the probability that only one ball is red. So that means we want red and then not red, or not red and then red. So we've got 1/4 times the third, which we just did. Oh, not times the third, my bad. Times 2/3. So we got 1 times 2 is 2, 4 times 3 is 12. Or we've got the 3/4 times the 1/3, which is 3/12. So just like before, we now need to add these together. Don't forget you don't add the bottom. So you've got 2/12, add 3/12, that makes 5/12. Next one, a bag contains coloured cubes identical except for their colour. The probability of choosing a red cube is at random from the box is 5 out of 7. A bag also containing similar colour cubes. The probability of choosing a red cube at random from the bag is 3 out of 5. Okay, so we've got a box and a bag. Chris takes a cube at random from the box and a cube at random from the bag. So if we know that choosing a red out of the box is 5 out of 7, so this is 5 out of 7. Not choosing a red, got to add it to 7 to make 1, so it's 2 out of 7. So at the bag, we know red cube is 3 out of 5, therefore this is 2 out of 5. They filled that bit in for us, so that's still 2 out of 5. Alright, question bit. To calculate the probability that neither of the chosen cubes is red. So we don't want a red, so we just want not a red and not a red. So we want 2 out of 7. Don't forget and means times out of 2 out of 5. So 2 times 2 is 4. And 7 5s are 35. So it's 4 out of 35. Right, question next one. A factory has 2 machines, A and B, which is used to make large numbers of certain items. Machine A is used to make 60% of the total output, and machine B is used for the remainder. Probability that an item made on machine A is rejected is 0.1. Probability that item made on machine B is rejected is 0.2, so it's going to be 0.2 here. We've got to complete the tree diagram. So if this is 0.1, we know this is going to be 0.9 because they've got to add up to 1. And if we know this is 0.2, this is going to be 0.8. Now we just need the machine used. So it said machine A is used to make 60% of the factory's total output. Okay, and machine B is used for the remainder. So this has got to be 60%. So I'm going to change that to a decimal so it's easier to use. So we know 60% is 0.6. And then we know B is going to be 0.4 because they said that's going to be the remainder. Right, we filled in our diagram. Now we've got to answer our question. So calculate probability that an item chosen at random is accepted. Wow, we've got 2 choices. It could be from machine A and accepted, or it could from machine B and accepted. So we've got 2 options here. So we've got 0.6 times 0.9. So when you times in decimals, just times your numbers. So you've got 6 times 9, which is 54. And then we need, look at our question, and we got 1 number, 2 numbers in total after our decimal. So we've got to have 2 numbers in total after our decimal. So it's going to be 0.54. And the bottom one, we've got 0.4 times 0.8. So we know 4 times 8 is 32. And we need 2 numbers after our decimal. So 2 numbers after our decimal. And now we need to add these up. So we've got 4 and 2, that's 6. 5 and 3, that's 8. So 0.86. We've got 86% chance of getting accepted.